Welcome back. So now we are going to look into syntax. So what is going on? Let's come back to what I told you in the first week, the introduction. I told you there are 5 fundamental shapes of data: trees, tables, cubes, graphs, unstructured data, text. These are the 5 fundamental shapes. Super important. This is the absolute fundamental. Those who understand this will have faster system and will be more productive. If you try to put data in a shape that doesn't match the shape of your system, then that's going to be slow and non-productive, right? So we are rebuilding the stack of big data from the very beginning, starting with storage, but we're done with storage, right? We've studied cloud storage with S3 and blob storage. We've studied HDFS. So now you know how to store things, right? We have a place to store things. But what were we storing? Bits. That's all we were storing. We were just looking at objects or files that are just sequences of bits, but we didn't really pay attention to what there is inside these files. So now it's time to actually start looking inside the files and seeing what we store in cloud storage or in HDFS. So I'll start with encoding and then syntax, which is for text files. And today I'll focus mostly, it's going to be maybe some JSON, and then next week XML, but you should know there's plenty of other kinds of syntax. CSV, I'm sure you know already. Okay, let's start with the encoding very quickly. I do it, I don't need to tell much about that, but the one thing you need to understand is in a computer, the only thing that is understood is zeros and ones, the bits. That's the only thing a computer can understand. And this is why this is all called digital, right? We have these zeros and ones. But where we want to store data, that data is understandable by us human. It's going to be, for example, text or numbers and so on, decimal numbers. When we read it on a screen, what we see is characters, letters, right? But in the computer, we have to map that to zeros and ones. This is what is an encoding. This is exactly what it is. So these are the names of some of the ways that you can map characters to zeros and ones. ASCII is one of the oldest one that was in the early days of the computer, where a lot of English-speaking people, so they just mapped the Latin alphabet. Then there's extensions. For example, in Europe, we have ISO Latin 1 in Western Europe that extends with the accents, the umlaut in German, and so on and so on. But now the more modern encodings would be UTF-8, UTF-16. They are better. So this is more international because this you can do here any language in the world, any alphabet in the world, and it's constantly updated. So if you have to pick an encoding, just pick UTF-8. That's kind of the default nowadays. This is a historical figure of the ASCII encoding. You can see how this was really based on English. So you have the letters here, A, B, C, this is uppercase. Then you have the lowercase letters. You have the decimal digits here. Then you have some punctuation and so on. And here you have things that not even I understand that are called control characters, right? So this is line feed, carriage return, right? So these are not real characters, so to say. But these are just the characters of English, and there was only 128 of them. Easy to remember, it's just like the size of the HDFS blocks, 128. All right. So why is UTF-8 interesting? Well, it's interesting because it's elastic, right? If you want to use fancy characters, you can. It will just expand to more bits. You don't need to understand the details of that. This is just to show you. And I also couldn't resist because it's Pi Day today, March 14th. So I had to have a pi somewhere. And this is how it's actually mapped to a sequence of bits. I repeat, you don't need to understand that. You don't need to understand how this is mapped. You just need to understand that we are mapping characters here in an elastic way to sequences of zeros and ones. Okay, that's encoding. I just wanted to make you aware. I'm sure you've experienced it, right? You download some file on the internet, you try to open it with a text editor, and all the umlauts and accents are just displayed in a weird way. Has it happened to you? Yeah, I see a lot of nodding. So yes, so this means that you're not opening with the right encoding. This is what happens. It might have been a UTF file and you try to open it in Latin 1 or that sort of things, right? So that's the trick. If it happens to you, just try to change the encoding. Okay, now I'm moving on. I start easy. I'm assuming you already saw CSV syntax. Everybody knows CSV syntax. The business people love it because on many websites, you can download stuff as CSV and then you can open it with a spreadsheet software, right? So what is CSV? It means comma-separated values. It means that you represent a table and you separate the cells of the tables with commas, right? You see the first row, that's the headers, ID, last name, first name. Then you have the first real row with 1 comma Einstein, comma Albert. You see here, the commas separate the cells, but this logically is a table, right? So this is called syntax. This is text. You see, this is text. And this text, of course, is going to be using UTF-8. You can store it as zeros and ones. But basically, we can represent a relational table as pure text, right? This is the one important thing in the syntax lecture. We are looking into how to represent data as text in a textual fashion. Now, CSV seems simple. It's not, because as soon as you want to have quotes and special characters, then it starts to be a bit of a mess. So for example, if you want quotes, so if you have a comma, let me just to show you how complex that is. If you have a comma here that you want to be part of your cell, you cannot have it just like that because it's going to believe that it's a cell general and then a cell special relativity, right? So you have to put quotes here and here to basically mean this comma here is a real comma that we want to see in the table, right? But the problem is that now if you want actual quotes in your cell here, then you also have to escape them by doubling them. So here you have a quote that opens the cell, then a double quote for that one, and incompleteness, a double quote to mean this is not the end of the cell, this is really just a quote, then we really close. So just to tell you, this is more complex than it seems, and what makes it more complicated is that even though there is a standard, in practice, it's a bit loose. And there's so many deviations, and almost every library has a different way of generating and reading CSV. You can also change. If you don't like commas, then you can use semicolons, or you can use tabs or spaces, and so on and so on. So just a warning that CSV is standardized, but in practice, it's a bit of a mess, right? So you're not surprised. Okay. So, but it exists, and this is how you represent relational tables as text, right? This is quite an achievement. All right. Now, if we can represent data as CSV, then why do we even need anything else, right? Why am I going to tell you about JSON today? Why does that even make sense? Well, I have to tell you a bit of a story before that, but it's only a repetition really of some things that I already told you. The first thing that I'm repeating from the first week to refresh your memory is that there are these normal forms that people like to have when they have relational databases and data organized in tables. Again, to summarize, what is a high normal form? It means that you spread the data over multiple tables, and every table does a single thing. So you have one table that just does products, one table that just does people, one table that just does cities, and so on and so on and so on. So in a high normal form means you have plenty of tables, then you join these tables when you actually do your queries. And what's going to happen here is that this is where it goes. For the purpose of this lecture, we actually don't care so much about high normal forms in the context of big data. Why? Because if we spread the data over multiple tables too much, doing that at the petabyte scale is extremely expensive. This is the reason we try to avoid that. So we denormalize by, instead of having multiple tables, we just put everything in the same table, and that's going to be fine for the purpose of big data, right? So we throw these normal forms away, and we don't really need to worry about the Boyce Code normal form or even the second or third normal form in this lecture. Why? If you want a quick explanation to shine in parties, then the reason is that when we read data with Hadoop or Spark and we read it from S3 or HDFS, it's a read-intensive workload. We read the data, we scan the data, we don't modify the data, we just read it. This is very different from what you do in a relational database for the business operations of a company, where you keep writing to the database, right? But then you use PostgreSQL or IBM, Microsoft, Oracle, and so on, and then you do the normal forms and so on, right? It's write intensive. But again, because here we are looking at petabytes of data and all we want to do is read it, scan through it, then we can denormalize our data and we can avoid joins because the joins are basically pre-computed because we directly get a big table. All right. So in a relational database, you might want to do that, spread across tables, but for the purpose of big data, you just merge it all into a single table, right? And we are fine with that. It has a cost. You see there's duplicates here. That's the cost to pay for merging into a single table. Here it was not duplicated, but now we have duplicates. But since we just read the data, we don't care about the duplicates. It's totally fine to us. All right. Okay, so we can consider for the purpose of Spark and MapReduce that we have a single table, a single collection. And now what I want to show you, I already said in the first week, is that if you look at one row of that table, one row, it's technically mapping strings to values, right? In this row, you map product to phone, you map price to 800, you map customer to John, and you map quantity to 1, which is just repeated right there, right? It's just a map from the attribute names to the actual values. Now, this is the same thing, but in a different representation, right? It's the same thing, really. But this is in fact called the JSON syntax. This is the JSON syntax. It means JavaScript object notation, and this is what we will study today and next week, right? And I want to show you that this goes beyond CSV, because this is a table, we could have done it in CSV, right? If I give you this table, who could give me the CSV file for that? It's easy, right? You just put commas to separate each cell and then new lines to separate the rows, right? But here I didn't do it in CSV, I did it in JSON. I will need to justify myself. I will need to explain why I'm using JSON and what added value JSON brings to us, because this is more complex than CSV, right? There's quotes, there's curly braces and columns and so on and so on. So it's more complicated than CSV. And it's also very verbose, right? Because now if I do it, this is just the first row. Now if I do it for all the rows, that's very, very repetitive, right? Look, product, 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 price, 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 customer, 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 very repetitive. So here it sounds, if you just study that use case, that might be somewhere you could argue, okay, CSV is better. CSV takes less space than JSON, right? But I'll show you in a moment why this is actually useful. Because in the beautiful world of SQL, so the relational databases of the 70s, we had 3 rules. The first rule was that all the rows in your table must have the same columns. That's why it's called the table in the first place, right? Every row, every tuple must have exactly the same attributes. There's the second rule that says that you cannot nest. You cannot have a table in a table in a table in a table. That's forbidden. That's the second rule. All your values must be atomic integrity. And the third rule means that if you look in a column, all the values have the same type. These are all integers, these are all strings, these are all integers. So you see how the regular structure and pattern is. This is called domain integrity. So the first normal form, again, this is the idea that you have tables in tables. Well, this is where it goes. Just like together with the Boyce Code normal form, we are dropping all of that. And we are leaving the world of SQL to go to the world of NoSQL, where we don't care anymore, or we do not enforce anymore these 3 things: domain integrity, atomic integrity, and relational integrity. And I have examples for you. So this is an example where we break relational integrity or table integrity. No, sorry, not that one. We break atomic integrity. We break atomic integrity by having tables in tables in tables in tables. Right? So this is no longer a relational table in the sense of the atomic integrity, right? But here's the thing: in CSV, no way. There is no way you can. Well, it would be circumvoluted, let's say, if you do it in CSV. That doesn't work, right? CSV is really when it's an atomic form. But in JSON, no problem at all. In JSON, all you need to do is, so you have product and price, that's easy, right? Phone 800. Orders, just put square brackets in there, that's called square brackets, it's called an array, and then the 3 objects here that corresponds to the 3 rows of that table, comma separated. This is what you can do with JSON that you cannot do with CSV. So now you maybe start understanding that the reason why we use these new syntaxes, JSON and XML, is because of that. Because if we are strictly in SQL territory, then CSV is just fine. But if we leave the SQL territory by dropping atomic integrity, by dropping in relational integrity, by dropping domain integrity, and even by dropping the Boyce code normal form, then CSV doesn't work anymore, but JSON does. So this is how you would represent this row in JSON syntax. And of course, we'll go into details of the JSON syntax, right? This is just the appetizer here. But now something even cooler. Here, we just break atomic integrity. Let's break other things. Let's break relational integrity. How do I do that? I remove the cell here. It's not even a table anymore, this nested thing, right? I have a missing cell in here, see? But in JSON, it's easy. Just remove the corresponding quantity, and that's it. You just have customer Mary, but that's it. Let's break other things. Let's break domain integrity. Let's break domain integrity by storing things that are totally unrelated. Here I have text, and here I have an integer. So I broke domain integrity and put whatever in there. In JSON, I don't care. This is just a string, quote it, and this is an integer, and it works. Nobody is going to complain, right? So I can break all of these things in the JSON syntax, and I can represent even broken data or messy data is the proper name to call it. Who is following? Okay, awesome. So if you look at all the things you can break things but by putting tables in tables in tables in tables, this thing here, nested values. You can break things by omitting cells, missing values. This is what we did here. You can break things with invalid values, meaning that you can have here text that wouldn't be an integer. You can break things with extra values, so that I didn't do in the previous example, but you can also add extra values, but you can understand in JSON, it's easy. Just add a comma and then the extra attributes, and it will just work, right? And that's it. So you can break all of that. And what you're doing when you break all of these rules is that you go from the wonderful world of flat homogeneous SQL to the even more wonderful world of nested heterogeneous data sets, right? This is the land of CSV. This is the land of JSON and XML, okay? And again, to give you another example, I have here this table that would be stored in a relational database, but you see it's very efficient because I have nulls. I'm forced basically in a relational database to put nulls because of relational integrity. But now I can notice that there are duplicates, so A, B, B, so I can just now break the rules and just put A and foo and then have tables in tables. Then I can break things even more by having a cell that is not there. But you see, this is just a drawing, so a visual for our brains as humans, it's easier to visualize. But this is what it ends up being in JSON, right? You can have 1 alpha, B1, C alpha, and so on. It just works. So in JSON, you can absolutely do this. In CSV, you couldn't. For whom is it clear that CSV is not powerful enough to store what there is on the right, but JSON is? Okay, most of you. Very good. What we have just done by breaking all of these rules is we entered the world of semi-structured data. Structured data, that would be CSV and relational tables, SQL. Semi-structured, it means that you break these rules and you can have additional or missing values, incompatible types, and so on and so on. Unstructured, I'm leaving aside. We are not doing this in this lecture. Okay. What is really nice is that we have standards. The syntax JSON and the other syntax XML, which we will cover, they have been standardized. What it means is that there's groups of very smart people that had long meetings during years, and they agreed on a standard. You wouldn't imagine how much effort it is. When you have 20 companies or 30 companies with each their own agenda and plans and so on, but they make the effort of meeting to reach an agreement because they realize there is more to benefit from if you standardize things and stick to the same standards than if every company does something different, right? The benefit of having a standard is that if you want to read JSON or XML files, you can just easily find a library in pretty much any language. You want to read XML or JSON in Python? No problem. Just you will find a pip package that does that. You want to do it in R, I'm pretty sure you will find something as well. In Java, in C++, in any language, you will find XML and JSON libraries. Why? Because it is so standardized and so widely used in the whole world that you will have these libraries, open source, free. So this is the benefit. W3C is the same institution that standardizes the web, HTML, HTTP, and so on, founded by Sir Tim Berners-Lee. And ECMA, so the W3C also standardizes XML. ECMA is the JavaScript, is what they standardized, and they also standardize the JSON, right? So XML is a W3C standard, JSON is now an ECMA standard. All right, this is the appetizer. Now I'm going to go more into details into the syntax, and especially make sure that you understand JSON. But first, a bit of high-level things. JSON and XML, these are called languages. So when I say language, you might think of English, German, French, Chinese, Hindi, Arabic, and so on, right? Like human languages. You might also think of computer languages, Java, C++, R, and so on and so on. But in fact, syntax is also a language. What is a language? It's just a set of text files that you accept as being part of the language. What it means concretely is that if I give you a text document, .txt, right? I give you a text document, and then I ask you a yes/no question. Yes or no, is that text document JSON? Yes or no, is that text document CSV? Yes or no, is that text document XML? It's a yes/no answer, yes or no. When you have some way of answering yes or no, I accept it, I don't accept it, then you have a language. And the language is basically the set of all the text documents that you accept, right? That's what it is. The name for that is well-formed. A text document is well-formed if the answer is yes. Of course, it depends on the language, right? A document might be well-formed JSON, or it can be well-formed CSV, or it can be well-formed XML, and so on and so on. All right. Remember that well-formed. Why do I insist on that? Because many people say valid instead of well-formed. They shouldn't say valid. Valid is something else that we will see in 2 or 3 weeks. Do not say valid, say well-formed. Well-formed means you can open it with an XML or JSON library and make sense of it. Okay, now this is XML syntax. Who already saw that kind of syntax? Maybe nobody, but it might remind you of HTML. Who saw HTML already? Some of you. It's a cousin of HTML. In fact, it was invented more or less by the same people. So they all follow from an earlier technology that was called SGML. Anyway, this is XML. It's just like JSON. We will see that XML and JSON are really 2 ways of storing data that breaks the rules that we've seen before. All right, so this is XML, this is JSON, right? So now you'll start to be familiar with that because JSON I've already exposed you to. I already showed you a few examples. So how do you recognize them? Well, it's easy. XML, you just see these angle brackets here, smaller than, greater than. That's how you recognize XML. And JSON you recognize because it has these curly braces and it has these square brackets, comma separated, and so on, right? This is how you recognize JSON. But of course, we look at the details of that, right? Okay, so XML, JSON, and we have 5 minutes, a few minutes left, so I'll start with JSON. Why do I start with JSON? Because it's easy. It's really super easy to learn, and it fits. I think the JSON.org page, it's longer now. I think they added stuff, but back then it was a very small page that had it completely. So what do we have in JSON? The way I think about it is we have 6 kinds of values, 6 building blocks, if you will. The first building block is strings. And these strings, they look exactly the same as in many programming languages. In Python, in Java, in C++, you have these quotes around them, right? So this is string foo. And then, of course, that's the same. It shouldn't surprise you. This is the same also as in C++, Java, and so on. What about special characters? What if you have a string and then you want a new line or pi or whatever in the middle? Well, you just use the backslash. So the backslash, for example, here, \n means that it's a new line. \u means that you enter a code for a character. So this is the next 4, 005F is the code for some character. I don't know what character it is actually. It might be, yeah, I will look it up. But this is basically just if you want a special character, you can just use \u and put the code. The code is looked up in a catalog, right? So typically you can open a search engine and say what you want. Like for example, you want a field square, then type field square Unicode character, and then you will find some catalog and it will give you the code of that character, right? There are millions of them, so a lot to take from. Then we have numbers. It's easy again because they look exactly the same as in many languages. You have the decimal periods to have, you know, if you want decimal numbers, you have the negative sign if you want negative numbers. You have the E, that is basically the scientific notation, right? You find that on calculators as well. So that means times 100,000, 10 to the power of 5, right? What it tells you is that the dot should be shifted by 5 to basically give you. That's the scientific notation. These are numbers. Then you have Booleans. It's easy, it's true or it's false, right? Yes or no, true or false. No quotes, just like that, true, false. Then you have null. Null is just like the SQL null, right? You just have no value at all, so you put a null in there. That's also something you might know from Java, C++. Whoever had a null pointer exception, because that's pretty much it. That's the same null. Okay. Then we have arrays with the angle brackets that are just ordered list of any values. It can even be a mess. Here it's a mess. That's totally fine. So it's a list of an array of 5 values here. And you have objects that basically are the maps, the original ones that you got from tuples on a row of a relational database, foo, bar, str, obj, and q. These would be 5 columns. If you see that as a row of a relational database, you can put any value in there. That's why I'm going to stop for today. Just these 6. You see 1, 2, 3, 4, 5, 6, and that's it, you know JSON, right? So we'll take it from there next week. We'll also look into XML. And I just want to know before you go that you followed. And then you're good to go. Oh, I need to click more somehow. That's this one. Ah, people understood everything. Several. There. I was running out of battery. So thank you very much. Seems like everybody is following. I will keep the pace. I'll see you next week at the usual time and enjoy the exercises this week on the cloud storage. Thank you very much. Goodbye. Have a nice day.